Hi, we have reached the end of the polynomial subtopic, which is partial fraction with the denominator in the form of quadratic that cannot be factorized. Alright, so what does it mean by quadratic that cannot be factorized? Well, it's whenever you press your calculator that EQN with degree 2, we see that maybe in your calculator you get something like Ri or something like .I or anything in that form, which refers to that it is an imaginary number. So it is considered as cannot be factorized. And also, if you press your calculator and you find something, the answer of your root of x is very long. So it's also considered as cannot be factorized because you cannot factorize it into two linear factors. Let's go ahead and look at the examples. Look at the first one. We have to look at the denominator one by one. This first denominator is x minus 2. So what is x minus 2? Is it linear or quadratic? You should know that x minus 2 is just linear. And please do check whether this is repeated linear or not. Well, since there's no square here, so it means that it's just linear, it's not repeated linear. So how to separate this? Start with that linear denominator, as you have learned in tutorial 4. Separate x minus 2, write it as one fraction. And then what you write on top of it as your numerator? Remember, the degree of the numerator must be 1 degree less than the denominator. So since the denominator is linear, x power 1, so the numerator must be x power 0, which is constant. That's why it's a here. Alright? Now let's look at the other denominator. It is x squared plus 7x plus 3. Now pause the video and try to press your calculator. See what you get, the answer for this. The answers that you might get from your calculator is negative 0.4586187734, and the other one is negative 6.5413811265. And then try to press this symbol on your calculator. Can you change these numbers into fractions? Well, you can't. So this is what we call as a quadratic factor that cannot be factorized, because you cannot simplify it and you cannot write this quadratic term expression into two linear factors. Alright, so since you cannot write it in two linear factors, so how to separate this is you have to write down x squared plus 7x plus 3 as the denominator, and then what should you write on top as your numerator? Well, remember, it's 1 degree less than the denominator. So since our denominator has degree 2, so our numerator must have degree 1. That's why we have x power 1 here. But you cannot just simply write bx on top. You have to write bx plus c. Why? Because it's linear. So the basic form of a linear expression is bx plus c. Now, let's look at the second example. Look at the denominator one by one. The first one on the left is x. This is x power 1. So is it linear factor or repeated linear factor or quadratic that cannot be factorized? Well, since this is just x power 1, so it's just linear. And how to separate linear? Remember, it's just writing x as the denominator, and then at the numerator is just the constant. Remember, whenever the denominator is linear, then your numerator must be constant. So please do take note of this note. Alright, looking at the next denominator. Next to x, there's the quadratic expression, which is 5x squared minus 6x plus 2. Now try to pause the video, press your calculator, and find out what's the value on your calculator. So after you have factorized, the answer that you will get on your calculator is 0.6, and on my calculator it's written as Ri there, on top, on the right hand side corner. So is the answer 0.6 or is the answer imaginary? Well, the answer is imaginary, since the roots of this quadratic expression is imaginary and it's not real, so we cannot factorize it. So we have to separate it with another fraction with the denominator of 5x squared minus 6x plus 2. And then on top, as the numerator, you have to write linear. Why is it linear? Remember, because the numerator must be 1 degree less than the denominator. So since the denominator is x power 2 or quadratic, so the numerator must be linear. Now let's look at the first example. To solve this question, you have to look at the denominator one by one. Look at the first expression of the denominator. The first expression of the denominator is x plus 2. There's no square there. So what type of denominator is this? This denominator is what we call as a linear factor. So how to separate it is we have to first write down this factor. It's linear. So remember, when the denominator is linear or x power 1, so the numerator must be a constant. So just write a on top. Okay? Next, when you look at the next denominator, it's x squared plus 1. This is quadratic, but can this quadratic be factorized into two linear factors? Try it out. And you see that on your calculator, you have that Ri symbol. So it means that you cannot factorize this x squared plus 1. Since you cannot factorize x squared plus 1, so you just have to write down this as the other fraction. And then what you should write on top is, please make sure that the numerator must be 1 degree less than the denominator. So since the degree of the denominator is x squared, so on top it must be linear. So make sure the linear is in the general linear form. So it is bx plus c. Next, we want to compare the numerators. So to compare numerators, the denominator on both left and right hand side must be the same. So what should you multiply with a? Remember, as in the previous tutorial, I've mentioned that you have to ignore the denominator under a, which is x plus 2. So compare that with the left hand side denominator. You also have to delete x plus 2 on the left hand side. So what's left is just x squared plus 1. So write that next to a. Multiply with x squared plus 1. Next, looking at the denominator under bx plus c. But don't forget to write down a bracket for bx plus c. Okay, so under bx plus c is x squared plus 1. So this means we have to delete x squared plus 1 as well on the left hand side denominator and see what's left. So you delete x squared plus 1 on the left, and what's left is x plus 2. Write that right next to bx plus c. Make sure you write your brackets here. Next, what is the best value of x that you should substitute in? So, same method applies. Look at the denominator on the left hand side and look at the factor one by one. So the first factor is x plus 2. Equate this to 0, so x is equal to negative 2. Your first number is negative 2. Substitute it into this yellow line. And after you have substituted, you can see that negative 2 plus 2 behind here will be 0. So 0 multiplied with all of this is just 0. So b and c goes. So the only thing left is just a term. When you simplify this, you will get 5a and 3 on the left side. So a is just equal to 3 over 5. Next choice of x. Let's look at the other denominator value. This is x squared plus 1. Equate this to 0. And you will see that this is imaginary number because you have square root negative 1. You cannot solve this, and it's not real. So this means we cannot use this value of x. So whenever you have this problem, there's no other values of x that you can substitute it in. So you can just choose any value of x besides the one that you have used, which is x minus 2. And also don't forget to substitute the constant that you have found, which is, for this question, a. Of course, the best choice of x would be an easy number, and for me it's 0, so you just substitute in 0 inside. Remember to substitute your value of a into your equation as well, not only just x equal to 0. Okay, so 0 times b is just 0, so this term goes, and then 0 plus 2 is 2, so what's left is just 2 times c, because b is 0. And on the front here, this is just 1 plus 0, 1 times 3 over 5. Simplify it until you obtain your value for c, which is going to be 6 over 5. Next, we also have the same problem. There's no more x that you can choose, so just choose any value of x. The next easier number besides 0 is just 1. So substitute in 1, and also don't forget to substitute your values that you have found, which is a constant and also c constant. Notice that I have substituted the values of a and c into my equation, and then also substitute x equal to 1. Now you're left only with b, so just simplify this equation. After a little bit of calculation, you will find out that b is equal to negative 3 over 5. So you write your final answer in terms of partial fractions. So refer to your first line here. Substitute a, b, and c back into that form. Write down the denominators first, and then substitute your values of a, b, and c. Remember, since a is a fraction, 3 over 5, so you should write 3 on top and 5 below. Just write bracket there. But for b and c, you cannot simply just do that. So I'm going to show you step by step. Write b first, and then x, and then plus c, which is 6 over 5. According to this formula, it's bx plus c, so you write your b, x next to it, and then plus 6 over 5. Take note that there is a negative in front of this x, but this negative is only for x, it's not for 6 over 5. So that means if you simply just multiply this negative with this positive sign and bring it to the front and write something, maybe something like this, then this is wrong. Because this negative will mean that it's for x and also for 6, which is wrong, because that negative is only for x. So the correct way in simplifying this expression is you have to factorize it. So make sure you have the same denominator. First, equalize the denominator. But since our denominator is the same, so we have 3x plus 6 on top. But make sure if I want to write negative in front, so that means it's a bracket here. But when I try to expand this, it will not be the same as the first expression, because it will be minus 6, which is wrong. So since I have taken out the negative sign, so to make it equal as the first expression, I have to write down minus sign here. So it's going to be negative 3x minus 6. When negative meets negative, it will be positive. So it will be like the same first expression. Next, can you see anything that you can factorize again? So here on top at the numerator, I can see that I can also factorize 3. So I can take out 3, and what's left is just 2. Now, once I have the numbers negative 3 over 5, I can just simply bring 5 downwards at the denominator, and then negative, I can multiply it with the positive sign in front because I have factorized it. And that's how you should write your answer. And that's the final answer. Please try out example 2, example 3, example 4, and I would like to discuss example 5 now. Look at example 5. We don't care what the numerator is, whether it's quadratic, whether it's constant or linear. The most important thing about our numerator is that it must be 1 degree, at least 1 degree less than our denominator's degree. because we are only learning about proper fraction. Okay, so to express this in partial fraction, your first step is to identify your denominators. Look at it one by one. The first denominator that I can see is x plus 3, and it's just x plus 3 power 1, so it's not repeated. So what I should write is just x plus 3 on my right hand side, and then since this is linear, remember, if it's linear, then my numerator must be constant. The next denominator is x squared plus 3x plus 1. It is quadratic, but can you factorize it? When you press your calculator, you find these two answers. They are very long, so this means that we cannot factorize this quadratic. Remember what we have to do when we can't factorize the quadratic term? You just have to write it as the denominator, and then what will be your numerator? It's 1 degree less. So if it's quadratic as your denominator, so the numerator must be linear. Write the general term of linear expression. Next step is to try to compare the numerators. And to compare the numerators, you have to multiply a with the other factor. Look at the denominator under a. It is x plus 3. So we have to delete x plus 3 as well on the left hand side denominator. Once you have deleted x plus 3 on the left hand side denominator, you will see that what's left is x squared plus 3x plus 1. So just write that. Next to a. Next is bx plus c. So make sure you write your brackets here because we want to multiply the factor with all of bx plus c. So what should we multiply it with? Look at the denominator under bx plus c. Delete that same denominator on the left hand side. So what's left is denominator x plus 3. So multiply bx plus c with x plus 3. And then choose your values of x. The first denominator value that I can see is x equal to negative 3. So substitute in x equal to negative 3. Make sure you always refer to this line when you want to substitute. And then, after you substitute, negative 3 plus 3, the value is 0. So 0 multiplied with all of this is just 0. So b and c goes. What's left is just a. We have found that a is equal to negative 2. The next value of x, you should get it from the other factor. But this other factor is a quadratic with very long numbers of x. So you will not choose this. So you can choose any other values of x, which is simpler. 0 is not used, so you can just simply use 0. And substitute your constant a into your expression as well. So replace a with negative 2 in front. Now, let's take a look. So 0 times b is 0. And here, this is 3 plus 0, which is 3. So you're left only with 3c. After a little bit of calculation, you find out that c is equal to 2. Next value of x, you can choose any value, but the next easier value is 1. Notice that I have substituted the values of c and also my a. And I've substituted x equal to 1. To simplify this is b times 1. So it will be b plus 2 and then multiplied with 4. So you have to expand this 4 into the brackets. After expansion, you find this is 4b plus 8. You will find that 4b is equal to 12, so b is equal to 3. Once you have found all the values of a, b, and c, you can substitute back into your first equation. Start by writing down your denominators and then add in your constants a, b, and c. So a is negative 2, b is positive 3, and then we have x next to b, and lastly c, positive 2. So there's nothing that we want to factorize on the last fraction. So that's your final answer. But notice that this negative can be brought in front. So you can also do that. And that would be your final answer. Okay, thank you for watching.